And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today we're looking at this little Aroma musical instrument amplifier. Yeah, it's got no sound. It's got Bluetooth on it as well. Quite a natty looking design, really. Aroma acoustic guitar amplifier. It's got a built-in battery. We can switch it on, and it does indeed have no sound. It's got Bluetooth on it, and it doesn't pair up. It does pair up with the Bluetooth. We just get nothing outputting from it. So clearly, it's got a bit of an issue. It belongs to my friend 2 doors down, named David, who very kindly has given me an adapter which I need to finish off a project which will be forthcoming here on Doz's Television Workshop. So yeah, let's get a screwdriver and start removing some screws and see if we can get into this thing. Right, I have to say I do like its style. It's very smart. Now apparently David was quite happily playing this, and then he got a bit of feedback and it went off. So yeah, I suspect we might have done for the output stage. He did take it to a guitar amplifier shop, but they couldn't do anything with it. So I did say I'd have a look. Right. Okay, well that's fairly straightforward, isn't it? We've got a single board, got a lithium ion battery down in the bottom, we've got quite a chunky speaker, we've got a port for some bass response. Yeah. So what is the output device? That output device is there. So I'm just going to break some of this sticky glue stuff off here. Oh, it's gooey. Just to remove the speaker, let's just check, see if the speaker's all right. It's gooey and horrible. I suppose if it's designed to be carted around between gigs and stuff, you would do this. I also really need to disconnect the battery. It's got the same goo on it. Right, let's see if that's freed it up enough to make a move. Yes, it has. Good. Just disconnect the battery. I don't want lots of current available while I'm poking around stuff. There we go. Okay. So yeah, first things first, let's see if we've got a functioning loudspeaker, shall we? Meter to ohms. See if I can get in on the pins on here. Have we just got an open circuit speaker? No, it's about 4 ohms. It says 4 ohms on the back of it. That works for me. I have to say this bass port, look, is flopping around. That one's sticking back in place. So we've probably got a blown output stage, which will be this piece here. It's a fairly straightforward looking board. And what is the output IC? Okay, it says Chipstar CS8622. Sparsely populated around there, it must be said. Okay. let's just check the continuity. So Class D amplifier, it needs a bit of filtration on its output. So you've got these two 100 microhenry inductors there. Let's just check to see if they're still intact. That one is good. That one is good. Okay. Wonder what else we've got going on. Should be some capacitors across it as well. Yes, there are. Let's just make sure that those haven't gone short circuit. That one's okay. Yeah, that one's okay. We're all good. It's probably the IC. So let's just get onto the internet, see if we can't find a data sheet for it, and make some measurements. Well, after a very brief internet search, we've got a data sheet. Much of it in Chinese. Looks like it's 4 ohms stable. Looks like it'll do 25 watts, 19 at 12.5 volts, 24 watts at 14 volts into 4 ohms. Anywhere between 6.5 and 18.5 volts. It's in an ESOP 16, certainly is. And we've got a sort of basic diagram here. Now this is a mono amplifier, so only one channel. And yeah, we've got all the data we need here. I think we can work it out. There's our output filter that we just measured. That looks all right. We've got an enable pin here, which we need to pull low. So we need to check we've got a low on that pin there. Various power supplies, very simple. So we've got VCC and analog ground there. This always seems to be coming from this PVCC rail. Quite a lot of filtration in there. Ground power pad, that means we've got a pad underneath it. And we've got our signal input there on pin 8. And INN going to ground for our 1 mic cap. So yeah, there's some block diagram there. Shows our output FETs. So that's good. And we've got a top view showing what all our pins are. And obviously some pin descriptions in Chinese. Okay. Well, I think we've got enough to have a measure round there and see what's actually going on. Okay, now we've got an idea what we're doing with this IC. What I've done is I've just tacked some wires onto the battery connector so I can run it from the power supply. I have measured the voltage of the battery in here, and it's only about 8 volts, which isn't really enough to run our chip, considering it said the minimum voltage was 8.5. So I think this is a boost converter here, which is taking the supply voltage up to be able to run the output amplifier. So we need to check that is functioning as well. So what I'm going to do here, I've got my power supply connected. I've got it set to 8 volts, and we're going to power up. And yeah, we're going to have take some measurements around the board. Let me just get my ground out of the way. I shall connect that back to the supply. Not the most accurate way of doing it, but close enough for government work. So power is actually on. So yes, we need to flick the little switch on the rear. We've got an LED showing, so that's good. So our power supply was coming up on pin 9. So I'm just going to apply a bit of the old magnification to the job. Give me one moment. 1, 2, 3, 4, 5, 6, 7, 8, 9. It comes in there, which is on the end of that capacitor there. So let's just see what we've got there. 0.5 volt. Well, that's not enough, is it? Let me check I haven't completely made a mistake. Now it's about 0.5 volt. So that's why we're not going anywhere. So this is our boost converter. You can take it that is the output voltage from there. Yeah, we've got nothing coming out of the boost converter. So is the boost converter not running because the chip has failed and we've got a short circuit on that pin, or some other reason? How am I going to isolate that? Let's trace it back through. So we've got, I will zoom in so you can see what on earth I'm attempting to do here. Right, this is the chip in question. Here is our boost converter here. So have we got power going into the boost converter for a start? Half a volt. No, we haven't then. So what boost converter IC have we got? Oh, it's another Chipstar. Okay. The output appears to come off these two diodes here into this inductor before it makes its way to the power amplifier on quite a large power trace. So if the boost converter is being loaded down, if I remove that inductor, maybe it'll come up. So let's just switch off and just get that inductor off the board. Right, I'm just going to apply a little leaded solder. Both sides are there. And we're going to sweat that inductor off. Where are my tweezers? They're here. This is where the tremor comes into its own when working with surface mount. Oh yeah. Okay, that's removed the inductor. Now, let us switch back on and see if we've got any action. Let's have the meter on a different camera so you can see. There we go. That's cooling down, so that's fine. Right, powered back up. We have our blue LED on. Have we got any voltage there? No, we haven't. Okay, so our boost converter is not running for some reason. So let's find a data sheet for that and have a look, see what's going on in there. Unless I can see anything blindingly obvious, like an input pin. Oh! There's a very blown transistor in there. I can see that. So, yeah, power off. I will attempt to show you. Let's take that off. It's come away with a housing as well, but never mind. That transistor there. Oh, and the pad's all scorched as well. So, where are you? There. That transistor in there is absolutely shot. Wonder what it is. I wonder what it was. It's marked Q1. Oh, this U3 has been rather warm in its life as well. Okay, what does that do? Oh, that takes the power supply. Oh, and sure enough, it switches it through to the boost converter. Comes along there. Do you know what? I wonder if I just short it out and see if we get any life. Let's do that. One thing I do need to make sure is this switch here. Is that switching everything? I think it is. Okay. Right. Yeah, that's interesting. So if I just put a wire link in there temporarily, maybe not so temporary, we'll see if the boost converter comes up. I'm going to limit the current a bit on the power supply. So yeah, let's just put a wire link in there very temporarily, just to see what happens. I'm going to want a little bit of kynar. So basically I don't know what this transistor is because it is scorched. However, it does appear to be switching the converter on. And to be honest, if that mains power switch switches this on and off at the back, I don't know why it's there. But let's just put that in. There we go. Let's just trim that off. Where have my trimmers gone? There they are. Right, let's connector back down. So, power going on. Well, we're certainly drawing a bit more current now. Let's just have a look on the output of the boost converter. Look at that. We've now got 12 volts. So if I switch that off at the rear, does it take that away? There's no point in that transistor being there. Ah, how strange. Why would you do that? Anyway, perhaps it's for anti-thump purposes. Just going to switch the power supply back off. Let's pop that inductor back down and see if the converter works. Right, well, it's full disclosure time. I've gone and lost the inductor, but never fear, I have some wire-ended ones here. This is 220 nanohenries. The other one was only a small surface mount, and we're only knocking the edges off that power supply, and there's a bucket load of decoupling already in there. So I'm just going to solder this fella in its place. I'm going to tin the ends of that first. I don't really find these leaded inductors anymore. I've got a sneaking suspicion they were good for a couple of amps. So this should provide at least a starting point. That other inductor, it may well have been a just a ferrite bead. So anyway, let's see if we can't just hang this in there. Let's see if it functions. Okay, that is back in. So let me just untangle my meter leads again. So, meter to volts. Switch on. Not drawing any current, possibly because we are switched off. There we go, we are on. And 12 volts on the converter. I'm just going to check on the output of the speakers. So I've got 6 volts there, we should have 6 volts there. Yes! By Joe, have we fixed it? Right, let's plug the speaker back in. Let's try that. Well, we appear to have some what would be called blow if we were in the guitar industry. Let's see if it connects to my Bluetooth.
He brings them back in line. Every twist and turn makes the magic shine. Cathodes and the crackle of the tubes amidst the dust. They play nostalgic tunes. Solder smoke and the faint aroma of time in each repair. An art that's so prime.
Well, that appears to be a win. Let's leave that there and box it up and go and give it back to David next door. Result. Pop that off, desolder the power connectors. Plug the battery back in. Final test.
Old TVs revived in a brand new way. On the side,
Brilliant.
they guide you to the door.
Well, I'm going to take that back round to David now, and I'm sure it'll make his day. As usual, thanks for watching. Click like, subscribe, do all that rubbish, and I'll see you soon here on Doz's Television Workshop. Cheers now. Bye.
With a gentle hand, he brings them back in line. Every twist and turn makes the magic shine. Cathodes and the crackle of the tubes amidst the dust. They play nostalgic tunes. Solder smoke and the faint aroma of time in each repair. An art that's so prime. Where wires twist and spark. Fix the picture, bring back color in the dark. Screens that buzz, it's magic on display. Old TVs revived in a brand new way. Circuit close, but we're getting closer. Neon signs, they guide you to the door. Tubes and screens like you've never seen before. Pulses hum as sparks begin to fly. In this tiny shop, dreams are set too high. In Doz's shop, with a touch of love, your picture's clear and true. In Doz's hands, pixels flicker back to life and stand. Microchips and vintage heart in a world of screens playing their parts. Circuit boards with stories to untangle. Every wire a promise at an angle. He bends the light through the lens, creating onyx nights. Oscillators creating sonic waves, bringing back the charm of retro days. Capacitors and resistors. In Doz's touch, there's no misfire. Transistors dance to the rhythm of repair. Through the glow, feels like magic fills the air. Voltage pulses, the tune's melodic run. A symphony of sparks where the work is never done. In